There's a huge range in different size, material and strength nozzles for your 3D printer, and if you're just starting out in 3D printing, or if you're looking at progressing on your maker's journey, this might seem like a daunting thing to get your head around. Luckily, it's actually quite simple and straightforward, and in this video I'm going to go through the most common differences between 3D printer nozzles, what these differences do, and which one or ones may be best for you. So, let's have a look. .3D printer nozzles come in many sizes and shapes, but when deciding which one or ones you'd like to use with your printer, it largely comes down to two main things. The diameter of the hole at the end of the nozzle, which denotes the volume of filament that can be extruded at any one time, and the material that the nozzle is made out of, which will affect its strength and its resilience. Beyond that, there's a whole range of different designs of nozzles out there, and once you've decided on the size and material that you want for your nozzle, you need to make sure that you're buying one that fits in your extruder and hot end setup. The manufacturer of your printer, or the extruder if you've bought that separately, should say what style nozzles will fit it. It used to be a bit of a chore to swap out your nozzle, but with the advent of quick swap nozzles such as the Revo from E3D, or that of the A1 from Bambu Labs, it's now much more convenient to simply swap between nozzles, ensuring you use the best size nozzle for that specific print. When talking about 3D printed nozzles, they're usually referred to by the size of the hole that they extrude through. So a 0.4mm nozzle has a 0.4mm diameter hole which it extrudes the filament through. Most 3D printers come pre-fitted with a 0.4mm nozzle, and it is largely considered the best default size for a printer nozzle. This is mainly because it has a good compromise between potential print quality and print speed. However, there is a number of reasons that you might want to switch to a different size nozzle. Moving to a smaller nozzle allows you to print much finer detail. This is because if you were to say move from a 0.4mm nozzle to a 0.2mm nozzle, it's then going to be laying down lines that are half as thick whilst it prints. Whilst printing with a small nozzle size allows you to print finer detail in the X and Y axis because it's laying down thinner lines, because at this size it's able to be more precise with its material placement, it often allows you to print in thinner layer heights, meaning that you can also print in better quality and resolution in the Z axis, which can be really good for things like vertical slopes. Now, whilst it does allow you to print in much finer detail, it does have a couple of drawbacks using a small nozzle size. One big one being it can take a lot longer to print. The other being, especially if you're using a particularly small nozzle size like 0.2mm, some materials may not be compatible with it due to its small nozzle diameter. If you go the other way, however, and swap out with a larger nozzle, then you will obviously reduce the level of detail that you can print in. If, however, you're generally printing larger items, or ones with minimal detail such as boxes or phone stands, the drop in detail may be barely noticeable, and it's going to allow you to print significantly faster, especially as it also allows you to print in much thicker layer heights. Counterintuitively, you can usually use a faster print speed with a smaller size nozzle than you can with a larger one. This is because the filament needs to be heated up to be extruded, and the larger the nozzle size, the more material needs heating up to keep up with that printing pace. Although you can use a much faster print speed with a 0.2mm nozzle than you can with a 0.6, because the 0.2mm nozzle is extruding a third of the amount of material, it's still going to take significantly longer to finish that print. Alright, let's have a look at what impact these different sized nozzles actually have on the prints. To start with, let's take the popular design, the Cali Dragon, and we'll print this with the slices preset designed for a 0.4mm nozzle with 0.16mm layer heights. With these settings, it will take approximately 40 minutes to print. The main reason you'd switch to a smaller nozzle is for finer detail. So whilst with the 0.4mm version, we left it with the optimal preset of 0.16mm layer height, for the 0.2mm nozzle, we'll use the 0.06mm fine preset. When sliced with these settings, it's expected to take around 2 hours and 15 minutes, so almost 3.5 times longer than our 0.4mm setting. Finally, let's switch to a 0.6mm nozzle with a layer height of 0.3mm. When sliced for this, the print is expected to take just 19 minutes. Now remember, all of these speeds are using the stock settings with these default presets, and by manually changing the speed settings, all three of these could in theory print significantly faster. So let's see how they all came out. Let's start with the one printed on the 0.4mm nozzle. It's come out pretty good quality, which can be expected as this is basically the standard nozzle for most printers. There's a good amount of detail all over the Dragon, and for the most part you need to look pretty closely to start seeing the layer lines, though they will look more obvious under this macro lens. There is some issues under the chin where there is some overhang, and the main quality issue is underneath the back of the horns, which are also overhangs, but also very small perimeters. This would be improved by slowing down print speeds for small areas, but for the most part this is a pretty solid print. The Creality Dragon printed with a 0.2mm nozzle, however, has a noticeably finer level of detail, which is expected of course. Even when looking very closely, the layer lines are almost completely undetectable to the naked eye. The overhang on the back of the horns has also come out much better. This is because if the overhang is less than half the width of the extrusion, then the overhang issues are less severe. This is largely affected by the ratio between the layer height and the width extrusion, so as we come down to a smaller nozzle size, we've also dropped down to a significantly lower layer height. Under the chin, however, due to the distance of the overhang, it actually came out worse in this version than that of the 0.4mm version, but on the whole, this is a far better quality print, even if it did take almost 4 times longer to print. Finally, let's take a look at the Dragon printed with the 0.6mm nozzle. This has actually come out the nicest of all three in terms of lack of defects. However, you can see the thick layer lines even without looking close. Whilst the overhang under the chin has come out the best of all three, due to the mix of thick layer lines and large extrusion widths, there is far less detail over the tips of the scales on the tail and the back. So as you saw there, using a smaller nozzle gives you more quality in your prints, and using a bigger nozzle gives you less quality in your prints. But let's look at some better examples of where these size nozzles really shine. Using a 0.4mm nozzle, it took me 40 minutes to print this Creality Dragon, and using the 0.6mm nozzle, it took around 19 minutes to print the same model. Also using the 0.6mm nozzle, it took me 39 minutes to print this Creality Dragon, which is 61% bigger than the original model, yet took 1 minute less than it took the 0.4mm nozzle to print this. Because of its larger size, the lower level of quality is far less noticeable, as the scale of details has also been enlarged. As a result, this large Creality Dragon seems more along the lines of the quality of the smaller Creality Dragon that was printed with the 0.4mm nozzle. So we've seen that larger nozzle sizes can print bigger and faster more efficiently, but the difference in detail between the Creality Dragons printed on the 0.2 and 0.4mm nozzles didn't seem to outweigh the almost 4 times longer print time. Well, it really comes down to what you're printing. These are some signs from my TARDIS lightbox design. Now, I've made versions of these suitable for 0.4mm nozzles and 0.2mm nozzles, but the ones designed for 0.2mm nozzles are a good example of where these nozzles can really shine. These signs are simple but involve some pretty small text. Again, these are the ones that I designed to take advantage of the fine detail capable of a 0.2mm nozzle. I have printed ones for 0.4mm nozzles which have less text and larger font, but these are going to be a better example for what we're looking at here. When printed with a 0.4mm nozzle, it struggled on the top sign and wasn't able to include some of the white in the text, leaving it broken and hard to read. But with the other sign that features even smaller text, it wasn't able to fill in the text at all. When we look at the exact same signs but printed with a 0.2mm nozzle, you can see that they've come out with significantly better detail, filling in all the text and making them perfectly readable. It's with details like this that the 0.2mm nozzle really shines, but with its ability to print at lower layer heights, it also gives you that ability to have much smoother curves and vertical slopes. So those are the primary benefits of different size nozzles. However, nozzles also come in a range of materials. All nozzles will eventually wear out through use as a result of friction and will need replacing. Most printers by default come fitted with either brass or stainless steel nozzles, and for standard 3D printing these are usually just fine. If you're just printing with PLA and PETG, then these brass or stainless steel nozzles should last a good amount of time before wearing out and needing to be replaced. If, however, you're printing with more abrasive materials, or you just want your nozzle to last as long as possible between changes, you can also get more resilient nozzles made of harder materials. One of the most common is hardened steel, which is ideal if you're regularly printing with more abrasive material. It will still eventually wear out through use, but it's going to last you a lot longer. If that's still not hard enough for you, depending on your printer, you may even be able to get a ruby tipped nozzle. Whilst the bulk of it is still made of brass to retain good heat conductivity, the Olsen Ruby nozzle is largely considered the most wear-resistant nozzle in the world, which the makers, 3D Werksten, like to advertise was designed for printing with boron carbide, the third hardest known material in the world. However, even if they do have one compatible with your printer, at £85 for what is technically a consumable, I'd still only suggest getting one of these if you really need it. Now, whilst most are very similar, there is some variations to the internal structure of nozzles, including these from Bondtech, where the internal hole divides into three, with the intention of splitting the filament into 3 strands, therefore increasing the surface area and allowing it to melt faster, which in theory allows you to print significantly faster. Now, there is some debate about how effective this is, but it is something I'm going to be experimenting with down the line, and I'll of course let you know how that goes. Either way, I love the concept. Hopefully this has helped you better understand what different nozzles are for and which ones might be right for you. If you found this video useful, please do mash those like and subscribe buttons, both making my day and ensuring you get some 3D Revolution goodness in your feed in the future. You can now become a member of the channel, both supporting me and getting yourself a load of 3D Revolution goodies by hitting the join button either on my channel or below one of my videos. For now, thanks very much everyone, and until next time, happy printing. A big shout out to all my 3D revolutionaries. Thank you guys so much for your support, it means a lot. For everyone else, if you'd like to join them and become a 3D revolutionary yourself, hit the join button below my video and follow the instructions. For now everyone, why not check out some of my other videos where you can learn how to change the nozzle on your printer or just sit back and have some fun. Thanks very much, until next time, happy printing.